Hello, my name is Kiera Searacy, and I'm a master's student at the University of Kentucky. Today I'm going to be talking about weed management strategies for establishing Kentucky bluegrass as a perennial cover crop in a continuous corn system. Ask, why cover crops? Well, cover crops are a crop grown not for harvest, but to benefit the ecosystem in different areas in the ecosystem. For example, it will help build soil aggregation, encourage biodiversity, help with nutrient cycling and leaching of nutrients. But what we're focused on most here is weed suppression abilities. You might ask, why perennial cover crops instead of annual cover crops? Perennial cover crops offer a different solution, meaning they won't have to be planted year after year, and you can leave them in the field persisting for several years. This will help with labor and cost of seed, which could be viable to a farmer.
On September 18th, we planted the Kentucky bluegrass with a seed drill. Following planting, we sprayed a blanket treatment of glyphosate over all of the plots. There are 12 main plots that are dictated by the amount of times they receive a post-emergent herbicide spray. In this case, we use dicamba, and the plot either gets sprayed once in the spring, twice, with once being in the fall and once in the spring, or never, to assess what would be best at managing weedy populations. Each of these main plots is further divided into 7 subplots. The subplots have 4 pre-emergent herbicides, a nurse crop of oats, and a control treatment. The 4 pre-emergent herbicides are pendimethalin, clopyralid, S-metolachlor, and mesotrione. These are sprayed at the time of planting to limit weed competition in the beginning of establishment when the perennial cover crop is most susceptible to weed interference. There was also a nurse crop of oats planted the same day as the pre-emergent herbicide treatment and perennial cover crop planting. All plots received supplemental irrigation with an irrigation gun due to the lack of rain following planting. Lastly, the last subplot treatment was a second pendimethalin treatment applied at the tillering of grass on November 3rd.
The knowledge gap we are trying to assess here is how the herbicides will react with the Kentucky bluegrass and whether the Kentucky bluegrass will be allowed to persist in the system or if it'll be too effective at controlling both the weeds and the Kentucky bluegrass.
There are some challenges to establishing Kentucky bluegrass as a perennial cover crop. Because Kentucky bluegrass is slow growing and has a small seedling, this makes it susceptible to being outcompeted by weeds in early stages of growth. On the other hand, Kentucky bluegrass has characteristics that make it an ideal candidate to be a perennial cover crop. It has a shallow root system that will not compete with the corn when it is planted. It has a thick carpet-like establishment to help it outcompete weeds, and has summer dormancy, so it will not compete with the corn for nutrients during growing season. To evaluate the grass and weed establishment, there are 2 quadrats that are each a 1/4 meter squared placed in each subplot. One is in the north end of the subplot and the other is in the south end of the subplot, and that is representative of that area of the plot. Each of these is then separated into 25 equal-sized rectangles, and each rectangle is evaluated for the presence of weeds and the perennial cover crop. A random number generator is used to select 5 of the 25 rectangles, and the weeds are counted to evaluate the density in each of these 5.
Overall, we're trying to establish the slow-growing Kentucky bluegrass, identify potential barriers to establishing this bluegrass, and overall create a functional, perennialized, continuous corn system.
I would like to thank my advisor, Dr. Aaron Haramoto, the USDA NEFA grant who funds this project, Matthew Allen, Hallie Sandine, Alexander Garish, and Juan Renard for everything they've done to help with this video and my thesis project.